Hey, it's John from Gattis Garage. Today we're working on mounting our perimeter brake rotor. Hey everybody, welcome back. Saturday in the shop. We're going to try and get our wheel buttoned up. If you saw last week, we got it all welded together, but we got a bunch of parts to machine to mount the brake rotor, so not sure how much I'll get done today. I was in bed yesterday with 102 fever all day, so woke up this morning, fever was gone, so I'm back in the shop, but no idea how long I'll last. So we got 6 spacers to machine, and then we're going to make some bolt caps, and then we got to cut some tabs to weld to the wheel. So it's a pretty intricate little process for a brake rotor mount, but I think in the end it'll be worthwhile, and then our wheel will be complete. We'll be able to move on to the front wheel, and then I think we should have everything done that we need to get prepped for this build, so everything else will get done when the bike is built. So anyway, that's a good feeling. I'm going to get out there and get going on the lathe. Alright, so first thing we needed to do is get some slugs of 1-inch round aluminum chopped off, so fired up the Evolution chop saw. We're cutting these roughly 1 1/8 inches. We want them to end up being 1 inch long, so just lopping those off quickly. Move over to the lathe. We're going to face off each one of them. There's going to be a lot of redundant work here. Basically what we're doing is making 6 parts, 3 different parts, 6 times each, so it's a lot of redundant work. Can get to be a little tedious, but it's just the nature of doing this thing. When you need this kind of stuff, the best way to do it is just to get out there and try and get in a routine, get rolling, and you can knock them out pretty quick. So after we faced them off, I took my parting tool, swapped it into the lathe, and I'm cutting the shoulder on the first one. Once we've got that, we zero the DRO, and we're able to go in and cut the shoulder on all the subsequent ones pretty quickly. Pardon my voice, I'm fighting off a nasty cold here. So anyway, once we got that parting done, you can see us swapping parts back and forth. We're going to go ahead and center drill each part. You could center drill and tap. I find it faster to change the parts than to change the tooling. So like in this instance, I've got the parting tool in, I'm cutting all those shoulders, and then when that's done, then I'm going to switch over to the center drill. I'll center drill all the parts, then change over to the regular drill bit, and so forth and so on. So I don't know that it's necessarily any quicker that way. It may be quicker to change the tooling each time, but anyway, so you can see here we're going in and center drilling. These parts are actually going to have 2 different dimension threads. The side on the brake rotor will be a 1/4 20. The side that mounts to the wheel will be a 3/8 16. So what I'm doing is I went ahead and drilled straight through with the number 7 drill, which is the 1/4 20 tap drill. That dimension isn't really too critical, so I just went ahead and punched it all the way through. That'll let us come back on the other side when we flip them around and drill to our determined depth to do our 3/8 thread. So we had our first bolt in here. The lathe is not spinning nearly as fast as it looks. This video is sped up, and I broke the tap, so it happens from time to time. Got another tap and got back to work. I felt it getting tight when I was running the first one, and I just didn't get to the switch in time to turn it off. So as I said, stuff happens. Luckily I have plenty of 1/4 20 taps in the shop, and we're able to get back to work. You can see now I'm kind of running it with one hand on the switch, so I can turn it on and off back it out a couple of times and just clear the chips out of the way. That's almost always what causes your tap to break, is when you have some chips bind up. And these taps, being as hard as they are, they're super brittle and will break relatively easily when they jam up. So again, this is a multi-part process. We're tapping 6 different parts. Same part actually, but 6 different ones, so that we have our 6 mounts for our brake rotor. So, almost finished with these parts. We got them flipped around now, and we're drilling out to a 5/16 dimension for our 3/8 tap. Drilling these a 1/2 inch deep. I still haven't got my tailstock DRO fabbed up yet, so I just added a little Sharpie mark on the drill bit for quick depth identification. That way I don't have to keep stopping and checking. I can just run the bit down to the mark. And then we're using our 3/8 taper tap just to get a couple of threads started. These will eventually need to be bottom tapped, which we'll do once we get over to the table and have a way to hold the bungs a little bit better. But for now, we're just getting a couple threads cut up at the top so we have somewhere to start the bottoming tap, which, if you're not familiar, will cut threads all the way deep into the bottom of a hole. Alright, so we're back over at the table, just fitting our bungs in here, taking a look at how they're going to work, lay it up on the wheel, get a quick eyeball. Next thing we're going to do is, I cut all the bolt caps. I did this off video. I just figured it was like, how much more lathe work do you guys want to watch me do? So we machine those up. Just a basic piece of 1-inch aluminum, little radius cut on the outside, 1/4 inch hole drilled and countersunk for a socket head cap screw. So I'm going to go ahead and bolt all these on to the rotor, and that'll give us our final dimension to figure out how long our mounting tabs need to be. That'll bolt to the aluminum bungs, and those will weld to the wheel. So again, it's a little bit of a complex design, but I don't know. Originally I thought to make the mounting bungs out of steel and weld it all together, but I just thought the aluminum would look a little bit nicer, and so that's the way I went. So you can see here, this is one of our mounting tabs. We cut these on the plasma table with some 1/4 inch steel plate. I'm just going to use a little spring clamp here to kind of get an eyeball on it. And we're real close to our dimensions with these after eyeballing them. So next thing to do was go ahead and center punch one of those. I'm not sure what happened to the video of that, but I took one of the aluminum bungs and used a transfer punch, lined it up where we want it, transfer punched that over, and that gave us our location that we need to drill a 3/8 clearance hole into all 6 of these tabs, which we'll do over on the milling machine. We just transfer punched the single one. We'll use that to line up on the milling machine, and then with square on our vise, we'll be able to just change them out individually, getting them located in the same spot and having everyone drilled exactly the same. Had we transfer punched them all, there's always room for variance when you're doing that. So here we are over at the mill, just center drilling and then swapping out to the 3/8 drill bit and drilling a clearance hole. Again, like I talked about before, I find it easier to change the tooling and not change the part. So you can see here we change the part, square it up. We'll get the center drill in there, center drill that just to keep our drill bit from walking around, and then we'll swap it out to a 3/8 twist drill and drill a hole there. We did this obviously 6 times, just like all the aluminum parts. We needed 6 of those to complete the job. So now that we got our tabs drilled, go ahead and run our bottoming taps, 3/8 16 bottoming tap. This will allow us to get all the way down to the 1/2 inch, all the way down to the bottom of the 1/2 inch long drill hole we made on our lathe previously. If you're not familiar with bottoming taps, it's just a real square-ended blunt tap. There's no taper. They're not good for starting threads, but they're great for getting down into the bottoms of holes. McMaster Carr sells really nice sets. You get 3 taps in a set, like in a one specific size. For example, these 3/8/16 comes with a tapered tap, a plug tap, and a bottoming tap. So they're really handy sets. They're not crazy expensive. And lately, anytime I need a tap I don't have, I buy one of those sets, and they're just super handy to have in the shop for doing all kinds of fab work. So something to keep in mind if you need to buy a tap. So the last thing we did was bolt on 3 of the tabs. Only had 3 bolts in the dimensions we needed, so I ordered some new bolts. And just a little bit of hand fitting, and we got our rotor fit onto the wheel nicely, squared up. Once we get our hardware, we'll bolt the other tabs on, hand fit those, and we'll be ready to weld. Alright guys, that's a wrap. We're out of here for today. Appreciate you being here and watching along. We hope to see you next time at Gattis Garage.